Welcome to Voyage Daily Tech, the most important news personalized for you every day, supported by Voyage.com.
After listening to today's news, you'll know, first, US auto giants suffer $53 billion in losses retreating from EVs, while China's BYD surges with 800% sales growth. So we'll discuss why this shift creates an existential threat for Detroit and what it means for the future of auto industry jobs. Second, a $100 billion software fund broke its own rules to lead a $350 million round into AI chip maker SambaNova. We'll explore how this signals a massive shift in AI investment strategy and what it means for the high-stakes hardware war against NVIDIA. Third, the EU threatens TikTok with a multi-billion-dollar fine, demanding it disable addictive design features like infinite scroll. We'll analyse why this is a turning point in tech regulation and how it could affect the core business model of all social media platforms. Fourth, Tesla plans a massive 100 gigawatt US solar factory to power the AI boom, dwarfing the entire country's current capacity. Today, we'll take a closer look at this audacious pivot and its implications for US energy independence and Tesla's high-risk strategy. Fifth, a $1.25 trillion plan for orbital data centers hits a physics roadblock as experts warn cooling remains an unsolved problem in space. This discussion will reveal how a fundamental law of physics challenges SpaceX's AI ambitions and what it means for the future of in-orbit computing. Let's start with a story that caught everyone by surprise. While American auto giants are hitting the brakes on electric cars, a former GM executive is now warning of an existential threat to the entire US auto industry. And this isn't just about corporate profits. It's a fundamental shift that could change the very nature of auto industry jobs. As we move towards simpler, software-defined cars, the skills required are changing dramatically. Research shows that traditional mechanical and assembly jobs are at risk, while there's a desperate need for software engineers and technicians who understand high-voltage systems. The United Auto Workers is already creating new training programs, but it's a race against time. A while back, we talked about how this shift isn't just EVs versus gas, it's cars versus robots. Moving from large chassis to high-precision servo motors and complex sensors means clean room conditions and a whole new supply chain. That's an even steeper skills reset, which is why the retraining we mentioned feels like a race. The retreat is staggering. Stellantis, the parent company of Jeep and Chrysler, just disclosed a $26 billion charge from its EV pullback, triggering a massive plunge in its stock. It's not alone. General Motors and Ford have already announced more than $27 billion in write-downs after losing billions on their own electric vehicle programs. We previously flagged that the $7,500 federal EV tax credit lapse hit US. Demand hard GM alone booked about a $1.6 billion hit. That pressure is now showing up as these massive write-downs. Meanwhile, Chinese automakers are hitting the accelerator hard. In just 5 years, their global market share has jumped nearly 70%, and their global EV sales have skyrocketed by an almost unbelievable 800%. China's automaker BYD has now officially surpassed Tesla in global EV sales. We said a while back that BYD had overtaken Tesla as the world's biggest EV maker. Today's numbers lock that in and show how quickly the ground is shifting. Continuing our last discussion on BYD's surge, the new piece here is the how. The secret to their success is a strategy called vertical integration. A recent teardown analysis revealed that a staggering 75% of the components in a BYD vehicle are made by BYD itself. So the thing is, they make their own batteries, their own electric motors, even their own semiconductors. This gives them a massive 15% cost advantage over competitors and lets them innovate at incredible speeds, while Western automakers are stuck coordinating with dozens of outside suppliers. This is the core of the conflict. The former GM executive, Terry Wojciechowski, put it bluntly, calling the Chinese auto industry an existential threat to the traditional automakers. The pressure is so intense that Ford CEO Jim Farley is framing his company's plan for new, smaller EVs as a Model T moment, stating their real competition isn't other global automakers, but the Chinese. So what does this Model T moment look like in practice? Ford has created a secret skunkworks team led by a former Tesla engineer to build a completely new, low-cost EV platform from the ground up. The goal is to compete on technology, not just price. They're focusing on creating a software-defined vehicle that is simpler to build, with 20% fewer parts and a wiring harness that's 4,000 feet shorter. This is their counterattack. But this upheaval isn't just shaking up the old guard. Believe it or not, even the pioneer Tesla is pivoting. Tech entrepreneur Elon Musk, who once warned that Chinese rivals would demolish the competition without trade barriers, just cancelled production of 2 of his oldest car models. The reason? He's repurposing a US factory to build humanoid robots instead. We previously broke down why converting a car plant into a robot factory is a monumental engineering challenge. This isn't swapping one car for another. You're talking clean room assembly, high precision servo motors, complex sensor stacks, and a specialized workforce. As we've discussed before, the idea that car AI can simply be ported to a humanoid is more marketing than mechanics. Walking and grasping is a very different problem than highway driving. And remember, Tesla just logged its first ever annual revenue decline about 3% to just under $95 billion, and profits plummeted 61% in the last quarter of the year. That backdrop, plus the hit from fading incentives and intensifying Chinese competition, helps explain the timing of this gamble. In parallel, Musk has been leaning into an AI-first narrative, channeling fresh capital into XAI despite mixed shareholder sentiment. A reminder, this pivot is as much about investor story as factory output. You have to understand, this isn't a retreat. It's a high-risk gamble to create an entirely new market. Musk has stated that Tesla is fundamentally an AI and robotics company, and he believes these Optimus robots could one day be worth more than the entire car business, potentially making Tesla a $25 trillion company. He's trying to sidestep the brutal EV price war by making a bet on a future where robots are a bigger business than cars. As we've said before, the software subscription engine he hoped for, think full self-driving, hasn't yet backfilled the hardware slowdown, which only raises the stakes on this pivot. This isn't just a trend, it's a massive power shift. Since 2019, the collective global market share of Detroit's Big Three has fallen from over 21% to an estimated 15.7%. In that same time, China's 2 largest car makers, BYD and Geely, have seen their combined share explode from less than 3% to over 11%. Speaking of high-stakes pivots into AI, the investment frenzy isn't just about robots and cars. The real money is chasing the foundational hardware that makes it all possible. Just look at Vista Equity Partners, a private equity giant with over $100 billion, which just broke its number 1 rule. Vista, a firm that states on its own website it invests exclusively in enterprise software, is suddenly throwing its weight into the brutal, high-stakes war for AI hardware. This move is significant because investors are realizing that the true foundational power in the AI revolution might not be in the software apps we use, but in the specialized hardware that makes them possible. The numbers back this up. In just the first quarter of 2023, private equity firms poured over $9 billion into the semiconductor industry. The fact that Vista, a software specialist, is now chasing that hardware value signals that the entire investment landscape is being redrawn by AI. They're leading a new funding round of over $350 million into the AI chip startup SambaNova systems, but that's not the whole picture. While this is a huge injection of cash, it's also a story of survival. Just a few years ago, in 2021, SambaNova was valued at over $5 billion. This new funding is almost certainly a down round, meaning the company is being valued at less than it was before. It's a stark reminder of just how brutally expensive and difficult it is to compete with an established giant like NVIDIA, even for the most well-funded startups. Continuing that theme, this round underlines how even well-capitalized challengers pay a steep tax just to stay in the race. And they're not alone. The deal is a direct shot at the undisputed king of AI chips, NVIDIA, with existing backer Intel, also planning to invest up to $150 million. In other words, those ally-enemy lines we said were blurring, keep moving. This is where the situation takes a more complex turn. This isn't just about new money, it's about old relationships and failed deals. Intel, one of the key investors now, previously held acquisition talks with SambaNova that completely stalled. Now, instead of buying them, they're funding them, and the connection is even tighter. Intel's CEO, Lip Bhutan, also serves as SambaNova's executive chairman. It's a complex web of partnerships and rivalries, all aimed at one thing: finding an alternative to NVIDIA's dominance. We've seen this play before, investors preserving optionality by financing potential partners and potential rivals at the same time. Here's where it gets interesting. This frenemy strategy from Intel is actually a hedge. Why would they fund a direct competitor? because independent tests have shown that Intel's own AI chips, the Gaudi 3 accelerators, have struggled to keep up with NVIDIA's latest hardware in certain tasks. Essentially, this investment is a way for Intel to have a stake in the race, even if their own horse isn't the guaranteed winner. They're playing both sides to make sure they have a piece of the action against NVIDIA. It echoes what we noted a while back. xAI tightened a vendor investor loop with NVIDIA and Cisco to secure supply, while OpenAI diversified silicon to avoid getting boxed into a single stack. The difference this time is the layer then, it was about shaping demand at the application level. Today, the hedge sits directly in the chip lane. This move is happening amid an absolute frenzy. Rival AI chipmaker Cerebras just raised $1 billion. Another competitor, Grok, struck a deal for NVIDIA to license its technology for $20 billion. And remember our point that real-time performance becomes a growth flywheel? These bets are aimed straight at that loop. And these aren't just copycat companies. They're all trying to beat NVIDIA with radically different technology. For instance, Grok's chip, the LPU, is built for pure speed in AI inference. That's the process of running an AI model. It has demonstrated incredible performance running popular language models at over 280 tokens per second. Think of that as words appearing on your screen. Cerebras, on the other hand, uses a wild design called a wafer scale engine, which is essentially one massive single processor the size of a dinner plate, containing 900,000 AI cores for immense computational power. SambaNova is also pivoting hard into this inference space, trying to carve out a niche where it can be faster and more efficient than NVIDIA. That real-time bar we talked about is exactly what these architectures are racing to clear just through very different bets. The message is clear. Big money is desperately searching for anyone who can challenge the throne, as global software stocks have recently wiped out nearly $1 trillion in value. We said the lines between allies and enemies are being redrawn. The capital is following. This isn't just another funding announcement. It's a signal that the AI arms race is forcing even the most disciplined software investors to bet on hardware. A company once seen as an acquisition target is now a heavily backed gladiator in the fight against NVIDIA, proving the battle for AI supremacy is officially rewriting the rules of investment. We called this a seismic shift a while back. Today's Vista, Intel, SambaNova triangle is that thesis moving from the application layer straight into the silicon. We're seeing this massive battle for hardware dominance, but at the same time, another tech giant is facing a completely different kind of threat, one that strikes at the core of its software. The European Union just told TikTok to change its addictive design or face a fine that could run into the tens of billions. The EU's preliminary investigation found the platform breached online safety rules, and the demands are an attack on the very features that make the app so successful. The Commission is suggesting TikTok disable its famous infinite scroll, implement screen time breaks, and change the core algorithms that feed users personalized content. So why are these particular features being targeted? The infinite scroll is what can lead to what researchers call doom scrolling, that compulsive, endless swiping that can have negative psychological effects. The EU is suggesting alternatives like load more buttons or numbered pages, which are designed to give your brain a natural stopping point. What's often overlooked, however, is that re-engineering, this isn't simple. It could disrupt the seamless experience users love and fundamentally change how the platform operates, impacting everything from server loads to how content creators get discovered. EU tech chief Henna Virkkunen put it bluntly, if TikTok wants to avoid a fine of up to 6% of its global annual turnover, it will have to change the design of their service in Europe. This all stems from the EU's Digital Services Act, or DSA. The crucial part is that the DSA requires these huge online platforms to actively assess and mitigate systemic risk to their users, and that now explicitly includes risk to mental health. This is a huge shift. The EU is essentially saying that a platform's design choices can be a source of harm that needs to be regulated. But TikTok is firing back. A spokesperson called the EU's findings a categorically false and entirely meritless depiction of our platform and said the company plans to challenge them. This challenge will be fascinating to watch because, legally speaking, the term addictive design is still a bit of a grey area. There isn't a universally agreed upon legal test to prove where highly engaging ends and psychologically harmful begins. This ambiguity is what TikTok's lawyers will likely seize upon, trying to argue that their platform is simply good at keeping users entertained, not that it's dangerously addictive. And make no mistake, this isn't just about TikTok. According to experts, this marks a seismic shift in how regulators are policing big tech. As one social media expert said, this is the first time a major regulator has said the design itself is the problem. It's a move from fighting toxic content to fighting toxic design. This is a consistent pattern, part of a much broader trend known as the Brussels effect, where the EU sets the global rulebook for tech. The EU has already hit other tech giants with massive fines. Apple and Meta have faced penalties for App Store and advertising violations, and X, formerly Twitter, was fined for deceptive design practices. This action against TikTok is consistent with a pattern of holding all major platforms, regardless of where they're from, to the same high standard. This entire showdown is being called a reality check for TikTok, but also a warning shot for every other social media platform. The central power struggle is no longer just about what you see online, but how the platform is engineered to keep you there. The era of maximizing engagement at all costs is now being directly challenged. The market is shifting from maximize engagement to engineer responsibility, and regulators are proving they now have the tools to enforce it. The implications are huge because this strikes at the very heart of the social media business model. The entire attention economy is built on maximizing the time you spend on the app to sell more ads. But if that's no longer allowed, what's the alternative? This regulatory pressure is forcing a massive rethink. We're seeing a push towards new models like subscriptions or direct creator payments that don't depend solely on keeping your eyeballs glued to the screen. This isn't just a fine, it could be the catalyst that fundamentally changes how the internet makes money. While regulators grapple with the psychological impact of software, the tech industry is already facing its next giant hurdle, finding the sheer power to run the AI of the future. And that brings us right back to Tesla. Now, get this. The company is actively hiring for a plan to build 100 gigawatts of solar manufacturing on American soil before the end of 2028. To put that number in perspective, the entire United States currently has just 65 gigawatts of solar module capacity. For solar cells, the most complex components, the US, has only 3.2 gigawatts. Tesla is planning to build more than the entire country's current capacity and a staggering 30 times its cell capacity in just a few short years. The sheer scale of this plan is hard to overstate. Building solar panels isn't just about assembling the final module. The real challenge lies in the upstream supply chain. We're talking about producing polysilicon, then forming it into ingots, slicing those into wafers, and finally turning the wafers into power generating cells. According to US government data, China controls nearly the entire global process with about 97% of wafer production and over 80% of cells. So Tesla isn't just building a factory, it's trying to build an entire industrial ecosystem from scratch. This massive pivot to solar comes at a critical time as the company's EV sales are flagging. This is a high stakes gamble. A while back, we said the US AI build-out was taking a secure power first, clean it up later path, locking in new gas capacity as data centers soak up hundreds of megawatts per campus and utilities rewire their grids around that load. The latest twist is Tesla proposing a different route, front-load domestic renewables at stunning scale so the AI era doesn't have to be fossil first. So what's the strategic angle here? Well, this is likely more than just a pivot away from slowing EV sales. Some experts see a much bigger play. After all, the rise of artificial intelligence is creating an electricity crisis. The International Energy Agency projects that by 2030, the power consumption of data centers will nearly double, mostly because of AI. A while back, we contrasted the US power now approach with Europe's push for sovereign AI, anchored in efficiency and renewables, and the Gulf's bid to buy its way into the AI stack. Today's update drops Tesla right into that energy AI chessboard at home. Tesla's energy division is already growing fast, and by becoming a massive solar producer, the company could be positioning itself as a vertically integrated utility for the AI era, powering the very data centers its own AI ambitions will require. A Tesla senior manager went on the record calling it an audacious, ambitious project, adding, "We need audacious, ambitious engineers and scientists to help us grow to massive scale. The stated goal is to challenge China's dominance and bring manufacturing back to the US." And continuing our recent discussion of Musk's space-side ambitions, those proposed orbital data centers powered by continuous solar, this move reads like the earthbound complement, lock down the renewable supply stack on the ground as well. However, if you zoom out, you'll see another layer of strategy at play. While publicly championing this Made in America plan, recent reports confirm that delegations from Elon Musk's companies have been visiting top Chinese solar firms. Interestingly enough, this isn't necessarily a contradiction. They're likely on a mission to scout or license cutting-edge technologies where China is leading, like advanced perovskite solar cells. It suggests that even with a goal of American manufacturing, they may recognize that tapping into Chinese expertise and equipment is essential to hit such an audacious target, but that's not the whole picture. This isn't Tesla's first attempt at solar. The company has struggled with solar manufacturing before. Its partnership with Panasonic at its New York factory fell apart in 2020, and the facility has since been used for other products. This history is what has analysts so worried. That New York facility was the infamous Gigafactory 2 in Buffalo, a cornerstone of the controversial 2016 acquisition of Solar City. That deal was plagued by financial issues from the start, and the factory never came close to meeting its production or job creation promises, leading to years of criticism and scrutiny. And then there's the track record of missed deadlines. Analysts are already calling these new solar targets aspirational rather than likely, pointing to a history of big promises on ambitious timelines that often do not pan out, from driverless cars to robotaxis. And this brings to mind something we flagged a while back. If the AI electricity demand curve disappoints, big power bets risk turning into stranded assets. In other cases, that exposure sat with utilities and their customers. Here, an overbuild could leave Tesla and its partners holding the bag. And there's another huge risk factor here that's completely out of Tesla's control: politics. A big reason this plan is even financially conceivable is the massive tax credits offered by the Inflation Reduction Act, or IRA. These subsidies are designed to make American manufacturing competitive. But the future of the IRA is a political football. If those subsidies were to be reduced or repealed by a future administration, the entire financial foundation of this 100 gigawatt dream could collapse, leaving it to compete with heavily state subsidized Asian imports on its own. As we've said before, who ultimately bears the risk matters, and if the policy cushion wobbles, private ambition can hit a hard wall very fast. Tesla is now betting its future on becoming a solar manufacturing titan, but it's a move that pits immense ambition directly against a history of struggling in the very same industry. Tesla's plan to power AI on Earth is audacious, but what really brought the future of computing to a head was the next development, taking data centers into orbit. A $1.25 trillion vision for the future just ran into a fundamental law of physics. A while back, we walked through SpaceX's eyebrow-raising filing to ultimately deploy up to 1 million satellites long, tethered chains of computing nodes meant to become orbital data centers. Elon Musk's plan to combine his rocket company SpaceX and his AI startup xAI hinges on a primary goal: building massive data centers in space. You might be asking, why would we need data centers in space? It really comes down to two things: speed and access. The killer app for in-space computing is processing the enormous amount of data collected by satellites right there in orbit. Think about real-time Earth observation for disaster response. Instead of waiting for massive files to be sent down to Earth, processed, and then acted upon, an AI in orbit could instantly detect a wildfire or a hurricane's change in direction and send an alert. This removes the delay or latency and could be a game changer for time-sensitive missions. Back then, we also noted the rest of the architecture, each node powered by its own solar arrays and results zipped back to Earth via optical links. NASA has already shown roughly 200 gigabit per second laser downlink, so communication speed isn't the primary bottleneck, but a top space industry CEO just put that aggressive timeline on ice. Dylan Taylor, the CEO of Voyager Technologies, revealed the single biggest unsolved problem, and it's a shocker. Cooling, which, as we previously flagged, SpaceX had expected to handle through radiative cooling in the vacuum of space. The catch is that data centers are basically giant, power-hungry heaters. On Earth, we spend billions on air conditioning and even build them underwater just to keep the servers from melting. In space, that problem gets exponentially harder. Taylor went on the record stating it's counterintuitive, but it is incredibly difficult to cool things down in the vacuum of space. On Earth, heat transfers through air or water. In space, there's no medium. All heat has to be dissipated through radiation, which means you need huge, specialized radiators constantly pointed away from the sun. So the vacuum will cool it for free idea we talked about earlier runs into harsh realities about radiator size, pointing, and keeping those systems uncontaminated. Now, this is where the situation gets tricky. We've talked about radiative cooling before. The only way to get rid of heat in a vacuum is through thermal radiation, basically. The hardware has to glow with invisible infrared light to shed its energy. This is incredibly inefficient compared to a fan or a water pump. To solve this, engineers are working on some truly sci-fi solutions. We're talking about massive unfolding radiator fins made of advanced composites, or even more exotic ideas like liquid droplet radiators, which would spray a fine mist of liquid into space to cool it before collecting it again. Without mastering these technologies, a powerful data center would cook itself in minutes. This isn't just a minor technicality. Taylor calls it a major barrier. Even with SpaceX's heavy lift rockets ready to haul components into orbit without a working cooling solution, the entire project stalls. We previously framed SpaceX's pivot as becoming an AI compute provider, not just a launch and connectivity company. Taylor's warning puts a question mark on how fast that pivot can become real. For some perspective, consider Microsoft's Project Natick, which proved that underwater data centers are a brilliant way to solve cooling on Earth. They submerged a data center off the coast of Scotland and found the servers were 8 times more reliable than on land, thanks to the natural cooling of the sea. But even with that success, Microsoft recently ended the project because it was just too difficult to scale. If building data centers under the sea is that hard, imagine the challenge in orbit. And the warning comes from a serious competitor. Taylor's company, Voyager Technologies, is a major player building the Starlab project that is set to replace the International Space Station. They have their own cloud computing device already on the ISS and are also racing to master data processing in space. Now, Voyager is taking a completely different path. While SpaceX is focused on vertical integration, their rockets launching their satellites for their data centers, Voyager is building a coalition. They're partnering with giants like Europe's Airbus and Japan's Mitsubishi. Their business model seems to be about becoming a neutral orbital landlord, providing the infrastructure, like their Starlab, for anyone to use. It's a classic walled garden versus open platform battle, and it's happening in low Earth orbit. So, while the ambition is to build AI empires in the stars, an expert in the field is clear that a 2-year timeline is aggressive. Remember, the scale SpaceX sketched orders of magnitude beyond today's nearly 10,000 Starlink satellites would multiply the radiator and thermal management problem across every single node. And yes, a while back we weighed the environmental calculus too. On Earth, data centers are tracking toward nearly 945 terawatt hours by 2030 and are guzzling water. Microsoft's AI workloads alone push usage into the billions of gallons in a single year, while launchers carry their own emissions and congestion costs. But today's update centers on a more immediate gate, physics before policy. And even if they solve the cooling problem, a whole new set of challenges emerges. Once you have a multinational data center in orbit, whose laws apply? The Outer Space Treaty of 1967 gives jurisdiction to the country that registered the spacecraft, but it says nothing about the data stored on it. This opens up a huge can of worms about data sovereignty, and new international treaties will be needed to figure out who owns and controls information that literally exists outside of any country. The technical race is on, but the legal and ethical race is just getting started.
That's it for today on Voyage Daily Tech. Follow, share, and stay tuned for daily updates coming your way tomorrow.